Hello, my name is Adam Collier, P1 Group, and this is our videography information training session for operations and maintenance for the Central Station air handlers here at Children's Mercy Research Tower. This air handler is numbered 80A, so this is a 100% outside air application for laboratory air conditioning and pressurization. So as you can see behind me here is the outside air duct. 100% of the air into this machine is from the outdoors. That's what it means, 100% outside air. The first filtration section is located right here. So we are filtering the 100% outside air before we go into the rest of the machine. This section also has our first coil, which is the heat recovery coil. That coil is got a glycol loop connected to it, so that is pre-treating the outside air for the ability for our other components for preheat and chilled water to not work as hard. There's no maintenance or anything required of this coil other than just making sure that the operations of the three-way valve are 100% open whenever the system is enabled. Right here we have the condensate receiver tank for the steam preheat. That's the next section. The preheat coil will modulate its valves in order to maintain discharge air temperature in the winter months. It is also a wing coil application where there's a face and bypass damper on that coil to modulate and capture as much heat as we possibly can. This condensate receiver does have routine maintenance required. You want to verify that the operation of the pumps is stable. You can test these by putting them in the hand mode and operating the pump. Just look for any unusual noises, sounds, vibrations, and ensure that the sight glass actually lowers whenever the pump is in operation so that you can tell that the pump is working. If it is not working, you'll have to disassemble the pump and see if there's any debris or anything clogging it, or if the pump itself has been compromised and is broken. The best practice on repairs for this is just to replace the pump in its entirety. The tank can stay, obviously. There is an isolation butterfly valve to isolate any existing water in the tank so that you can have easy removal of the pump and easy replacement of the pump. Here's a strainer a basket strainer that's going to collect any debris or any manufacturing sludge, anything oils, stuff like that. So that needs to also be inspected. I recommend at least annually. You'll open that up, you can clean the basket, and then you can return it back into its place. The next section for this air handler has our humidifier. The humidifier valve modulates to maintain discharge air humidity set point, and it's sized obviously appropriately for 100% outside air. So in the winter months when we're below 20 degrees outside, you should see quite a bit of humidity coming off of this machine right here in this section, and that's normal. Then the next item we have are the freeze stats for freeze protection of this chilled water coil. The chilled water coil also modulates to maintain discharge air set point in the summertime. If in the event that there's an issue with the preheat, that's where these freeze stats would trip to protect this coil from any breakage or freezing. The Metasys system will report an alarm if one of these has tripped. Due to the sheer size of the coil, we have multiple freeze stats in multiple locations that are all in a series configuration. Therefore, any one of them could be tripped, so you'll have to check all of them, not just one of them. The next section is our fan section. There's barometric backdraft dampers on each fan. This is a 12 fan array. Any given fan that does fail, you will be able to see that on your Paragon, and it'll report an alarm, and it'll flash red that one individual fan is not reporting any CFM. It's a totalized fan array, so we are measuring CFM at each fan and adding them together for your total CFM value, or cubic feet per minute, that the fan's delivering. Your variable frequency drive is right here, and it has all of the drives inside this NEMA 4 cabinet. Any one drive has an alarm. You will see that on the keypad and display, and it should point you to the issue at hand, whether it could be a motor failure or a wiring issue. There's literally no maintenance to these machines here, other than checking your filtration in the cabinet and making sure that that is clear and we've got good airflow for the heat rejection. The motors themselves, they do not need grease or oil. They are totally sealed and require no maintenance. They do have a run hour lifetime of them, so after about 10 years they may fail. So you'll just have to replace the motor at that point. We have seen motors last 15 years, even up to 20 years. So it's pretty uncommon for them to just inherently fail, unless there is something going on with the wiring itself that's caused the failure. Imbalance can also be an issue, so just ensure that when you do your maintenance, manually start each fan up and just listen for unusual noises or vibrations or anything of that magnitude, so that you can tell if there could be potentially a problem that needs to be corrected. If a fan goes out of balance, it's probably because it lost one of its weights for the balancing of that wheel from the factory. And if you do see vibration or anything of that magnitude, you need to just replace the entire blower wheel. You can't rebalance those wheels, for it's very difficult to do in the field, and it costs less money just to order a new one rather than doing a field balance of the wheel itself. After that, then you have your leaving air section. Here we have some safeties of high duct pressure, your high duct pressure limiter, and those are items that could potentially shut the machine down in the event there is a failure of a damper downstream in the duct and the pressure increases rapidly. That's there to protect the ductwork. So that would be another item that if the machine is off, you'll get an alarm from Metasys and it'll tell you that we are off on high static. You're going to have to find the problem, correct it, reset it, and see if you've got stable operation after that. This gray box is the brains of the machine. This is the control center for Metasys. Obviously, through your Johnson Controls training, you should know the input and output modules from that session. However, this is the location for it, and each air handler has its own control cabinet. Here is a Bell & Gossett 1510 series base mounted pump. This type of pump is typical to all the pumps on this project. This is a 25 horse model here that serves the heat recovery system. All right, so we're pumping glycol with this machine here. Duplex for redundancy. One pump only needs to run at a time, and that is typical of all the other pump skids on this floor. At the back section here is the suction side of the pump. This is where the water enters the pump volute, and in that section there is a basket strainer to protect the mechanical workings of the impeller. That does need to be inspected occasionally. We obviously have cleaned and treated the piping system and with all of the other systems as well, and have pulled the startup strainers out of there, and now it's just the simple basket strainer with the 1/8 inch relief holes, and any debris can get collected there, and you'll want to monitor your operating pressure across this strainer section with this gauge. You can valve it to see what the DP is across it. Once the DP gets above a couple of pounds differential, you'll want to inspect it. The next section is the actual volute, pump casing and impeller. It is serviceable. You can disassemble this machine here in order to replace seals. In the event a seal starts to leak, you'll pull off the bearing assembly and obviously replace the mechanical seal with only OEM manufactured parts. The coupling is a rubber face coupling. Also, just check it for unusual wear or noises. They usually last forever. However, they can become brittle over the years, and you just simply replace that entire coupling. If you ever have to remove the motor, you will have to realign the motor with the coupling. The best thing to do is to try to actually just get the coupling shivs separated without moving the motor or the pump itself, and then you don't have to align it again. But if you do move the motor, you will have to align it. They need to be aligned within 5/1000 of an inch, which has already been done for you. However, if you do need to do that, again, I'd recommend you have somebody trained that knows how to do pump alignment correctly. There are zerts on these motors for grease. About every 8,000 run hours is when you'll want to add grease. You only need about 1.5 ounces of approved Pyrex grease. So that's about 1 to 1.5 pumps of a grease gun into that bearing in order to properly lubricate it. Two series, Water Wizard, Airco, hydronic steam to hot water converter. So we're using plant steam to heat water for use in the laboratories, the domestic water, and for safety water as well. So safety water is this right here, this system here for any of the sinks in the laboratories. They're going to have a certain heated temperature of 120 degrees in order to clean instruments and do other things with that type of water. The main PID controller is located here. You can see the set point. It's set to 120. The actual temperature is right above that at 121 F. This item here is the alarm high limit. What it does is if the water temperature gets too high, say 140 degrees, it will open up a valve on top in order to blow down the boiler and make sure that it's not overheating. I highly recommend that whenever you do service on these, which you'll do annually, you want to blow them down, check for sediment, things of that magnitude. Once you cool this machine off, you need to stage up the heat and not just go straight to 120 degrees. It will actually overshoot and blast off its pop-off, okay? So I recommend you at least start like it's say 80 degrees, then step it up to 90 degrees, 100 degrees, 110, 120. Do that over about a 10-minute period, and you shouldn't see any sudden increases in temperature and have it pop off. Your steam valve's located here. Steam pressure operates around 10 pounds. You will hear popping and some noises whenever the steam valves are actuating, because that's condensate being blasted into steam, okay? But that's a normal sound. It's perfectly acceptable. There's recirculation lines, loop 1, loop 2, loop 3. So there's a recirc line for the domestic, for the lab water, and for the safety water. This is our clean RO water steam generators for the sterile laboratories, GMP, good manufacturing practices, and the vivarium lab, or the animal lab. So we're utilizing the reverse osmosis pure water from the old existing lab to generate steam to inject into the laboratory air handlers for humidification purposes only. It is a redundant set of boilers. You have one that can lead and take a majority of the load that's required, and in the event there's an issue with this one, it will automatically switch over to the other boiler. You'll need to obviously check the water level probes that are located on the back of the boiler. All of those set points are internal to the boiler. There's nothing that can be modified or changed through Metasys other than enable and disable. So you can basically turn it on and off, and that's about it. And then all the operational settings are contained within the main control board here. They do automatically operate. They'll automatically blow down. There's really no routine maintenance other than annually you'll want to inspect the heat exchanger where the steam to hot water to steam converter is. In the event you're not making the proper amount of steam, then you'll definitely want to inspect that as needed. All the fill and drain controls are all internal to this machine and is done automatically as well. Here's a relief fan for the 5th floor mechanical room. This is typical to all of the air moving apparatuses for this facility, meaning exhaust, makeup, or relief fans. They're all built by Greenheck. Model number, serial numbers located on every one of these machines. You'll need that information for parts. You always want to get OEM parts for this. Jordan Risco's the rep. These fans will come on to maintain space pressure on the 5th floor anytime we're in economizer of the main air handling systems, and the relief air is going into this floor for conditioning purposes, as well as giving it a site for relief dump of the quantity of air that we're trying to relieve. These fans will monitor the space pressure and stage up one at a time in order to maintain that pressure and modulate with their variable frequency drives to do such as well. You've got Baldor Super E motors, which is standard spec on all of the fans for this facility. They too also need lubrication every 8,000 run hours. So these fans in particular will not obviously run all the time. So most of the time in the summer they'll be off. But wintertime, yes, they will probably be on. So you'll have to calculate how many run hours you think have occurred in order to maintain the proper lubrication intervals. Other fans in the facility do run full time. So you'll need to ensure that you're getting to those quarterly and inspecting the lubrication requirements. There should be no adjustments needed on any of these fans. They've already been set up by our balancer in order to make sure that they're moving the proper airflow. If there's an airflow adjustment that needs to be made, you probably need to consult with them or us, P1. This is the backup chilled water system for the new data center for the research tower. This is simply a volume tank. You've got your chilled water pumps. They're inline pumps. They don't need any alignment or any adjustment. They operate off of a variable frequency drive. The motor lubrication frequency is the same, 8,000 hours, 1.5 ounces of grease per bearing. The primary use for this machine is for the backup chilled water to the data center. In the event the central plant chilled water fails, there's automatic valves that will switch over and start this chilled water system up. The remote evaporator is located here, and the condensing unit is actually on the roof of the OPC building, near the OPC building. The only thing you'll have to do there is check the coils for debris and clean those annually. Again, this chiller will run very, very small amounts of time, if any amount of time. And the automatic switchover is all based off of temperature. So if for some reason the central plant chilled water temperature gets above 50 degrees, this will automatically start and take over. These are the high plume Vecktor fans for the biosafety level 3 laboratory on the 4th floor. Your unimounted disconnect is here. This is a utility set fan, direct drive, no belts, and it's connected to a common plenum with backdraft damper, and that's a motorized damper. The damper gets opened by the control system to enable the fan. Once the damper is proven open, the variable frequency drive will modulate this fan to maintain a duct pressure. There's also a dilution air damper located here that is going to mix fresh air with the exhaust air to dilute it before it's exhausted to the atmosphere.